Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which changes a binary tree so that every node stores sum of all nodes in the left subtree. First, let us take an example. The idea is to traverse the given tree in bottom-up manner. For every node, recursively compute sum of nodes in left and right subtrees. Add sum of nodes in left subtree to current node and return sum of nodes under current subtree. Now, let us see the algorithm which will assist us in this. Let us also have a sample tree to test our algorithm. First, we pass the root node which is 1 into function update tree. So, root will point to 1. Since root is not null, we check if root is a leaf node. As 1 has both left and right child, it is not a leaf node. And we call the left and right subtrees of 1 recursively using a call stack. Root will now point to 2. Since root is not null and 2 is not a leaf node, we pass the left child of 2 which is 4 into the call stack. So root will now point to 4. We check if root is null. Since it is not, we check if root is a leaf node. Since node 4 does not have any child, it is a leaf node, and hence we return 4 to the call stack. We continue execution for root 2. Now the right child of 2, which is 5, is passed. So root will point to 5. Since root is not null, we check if 5 is a leaf node. As 5 does not have both child, so we return root data to the call stack. So 5 is returned. Now we add left sum to current node. So root will be equal to root plus left sum. Hence root will be equal to 6. We return sum of values under root. So we return 6 plus 5 which is equal to 11. We continue execution for root 1. Now we pass the right child of 1 which is 3. So root will point to 3. We check if root is not null or if it is a leaf node. Since neither is true, we pass the left child of 3 which is null. Since root is pointing to null, we return 0. We continue execution for root 3. Now right child of 3 which is 6 is passed. So root will point to 6. Again, we check if root is null or if it is a leaf node. Since 6 does not have a right and a left child, it is a leaf node, and we return root which is 6 to the call stack. We continue execution for node 3. Now we add left sum to current node. So root will now be equal to 3 plus 0 which is 3. We return root plus right sum. So we return 3 plus 6 which is equal to 9. We resume execution for node 1. Now we make root data to root data plus left sum. So root will now be equal to 12. Finally, we return root data plus right sum. So we return 12 plus 9 and finish execution for this program. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.